Hello class, Davis here. Let's talk about the solutions to quiz number 4. Quiz number 4 had two parts. It covered trig substitution and trig integration. The first problem, a trig integration problem, asks you to evaluate the integral sine cubed 4th theta cosine to the 6th 4th theta with respect to theta. The second problem, a trig substitution problem, asks you to consider the integral 27x squared divided by 4 plus 9x squared, all raised to the 3/2 power with respect to x. We were asked to find an appropriate trig substitution for the integral and then evaluate the integral. Alright, for the first problem, the in-class problem, a cursory inspection of the integrand yields that we have an odd power of sine and an even power of cosine. The oddness of the power of sine indicates to us that we should make a u substitution for u equals cosine 4 theta. With this choice of substitution, du is equal to negative 4 sine 4 theta d theta, and we can apply the trig identity sine squared theta is equal to 1 minus cosine squared theta one time to isolate a single power of sine here. The other two become 1 minus cosine squared theta. Thus we can perform the above u substitution. After making the substitution, we are left with 1/4 the integral u to the 8th minus u to the 6th. This integrates to 1/4 u to the 9th over 9 minus u to the 7th over 7 plus an arbitrary constant c. After plugging in the original variable, we are left with 1/4 cosine to the 9th of 4 theta divided by 9 plus minus cosine to the 7th 4 theta over 7, all plus an arbitrary constant. Alright, that concludes the in-class problem. For the take-home problem, our first instinct should be to look at the terms under the 3/2 power. We have a 4 plus 9x squared. What form is this of? It's of the form constant plus variable squared. Now this indicates to us that we should make the substitution x equals tangent theta. Based off of the trig identity, 1 plus tangent squared theta is equal to secant squared theta. So how do we choose this constant c? Well, we know that if we make the substitution x equals c tangent theta, once we plug this in, we're going to be squaring c and then multiplying it by 9. We then want this new constant, not the c, the constant that is c squared times 9 to be equal to this 4. So we solve the equation c squared times 9 is equal to 4 to find the appropriate c, which is 2/3. After making the substitution, x equals 2/3 tangent theta with dx equals 2/3 secant theta d theta, our integral becomes 27 2/3 tangent theta squared times divided by 4 plus 9 2/3 tangent theta squared to the 3/2 power. And I'm sorry if my face is covering this. This is 2 secant squared theta over 3 integrated with respect to theta. We simplify the numerator and denominator. The numerator becomes 8 tangent squared theta secant squared theta. This is because we square the 2/3 tangent theta, we get the tangent theta squared, we get the 2/3 squared. We have the 2/3 from the secant squared, so the 2/3 squared times the 2/3 outside is going to simplify to 8 over 27. Multiplied by 27 is simply 8. Now in the denominator, we're primarily in this step focused on what is 2/3 tangent theta squared. That's going to be 4 over 9 times tangent squared. So we apply the identity, 1 plus tangent squared theta is equal to secant squared theta. When we get 4 secant squared theta, all raised to the 3/2 in the denominator, 4 to the 3/2 is the square root of 4 raised to the third power, so the square root of 4 is 2, 2 cubed is 8, so we get a constant of 8 in the denominator, and we have secant squared to the 3/2 power, which is just secant cubed. Now secant squared divided by secant is 1 over secant, so our integral finally simplifies to tangent squared theta over secant squared theta, integrated with respect to theta. We apply the identity tangent squared theta is equal to secant squared theta minus 1, and divide through to find that our integral is equal to secant theta plus cosine theta integrated with respect to theta. Recall that the integral of secant is log of secant theta plus tangent of theta, and the integral of cosine theta is sine theta. So we have the following antiderivative, and what remains is to take our integral that we have found. Let me scroll back real quick. We found the antiderivative in terms of theta. We know tangent of theta is equal to 3x over 2. But we don't know what secant theta is or sine theta is. We need to build a comparison triangle to find the values of secant theta and sine theta in terms of x. So what was the defining relation? We knew that 3x over 2 is equal to tangent theta. So tangent is opposite over adjacent. Tangent of theta is the ratio of the opposite side over the adjacent side. So if the opposite side is 3x and the adjacent side is 2, then tangent of this angle will be 3x over 2. So by the Pythagorean theorem, we can calculate the remaining side to be the square root of 4 plus 9x squared, and we can find sine x, which is opposite over hypotenuse, and secant x, which is hypotenuse over adjacent. And with these, we can plug in to the expression on the previous page to find the antiderivative in terms of x. Alright, thank you for watching, and as always, you can reach me by leaving a comment below or emailing me at binger@math.ohio-state.edu. Thank you, and have a good evening.